Hello my dear friends, welcome to BYJU'S Exam Prep. So in this video, we'll be trying to understand what is a short trick to remember the heat generation formula. So let's begin the session and you'll be enjoying this session and you'll be able to get the benefit of this. So in this daily dose, let's quickly see as we know that one-dimensional heat conduction equation for a rectangular system, for a cylindrical system and for spherical system is basically looking something like this. And it's say like we are having so many formulas in our mechanical engineering. Again, we need to remember this formula. So I'll be telling you a simple technique how you can understand, how you can remember this formulation, and also we'll be taking the result formulation and a trick to remember that. So there's a generalized formulation which you can use to calculate this equation, that is the generalized one-dimensional heat conduction equation, that is 1 upon r to the power n del by del r to the power 1 del t by del r plus q dot by k is equal to 1 upon alpha del t by del t, where q dot is the heat generation per unit volume and r is the dimension. It could be in rectangular coordinates, that could be x, in cylindrical and your spherical coordinates it's radial, because we always do the analysis in the radial direction. So the question is, sir, how we can use this equation to get this? It's very easy. If we put n equal to 0, then you'll be getting a rectangular system, or we can say the slab. If you put n equal to 1, then you'll be getting a solid cylinder. You'll be getting a formulation for the solid cylinder. And if you put n equal to 2, then you'll be getting the formulation for the solid sphere. You can cross check. Let us suppose I'm placing n equal to 0 and I'm assuming r is tending to x, because normally in case of rectangular coordinates we are defining in x, y and z. If you put n equal to 0, that will be 1 upon del by, if you write it over here, 1 upon del x into del t by del x plus q dot by k is equal to 1 upon alpha del t by del small t, that is with respect to time, where alpha is thermal diffusivity. So we can say this is del 2t by del x square plus q dot by k is equal to 1 upon alpha del t by del t. So I think the same equation you are getting over here, that is for the rectangular system, that is for a slab, right? So similarly, if you put r equal to 1 and r equal to 2, you can get for the solid sphere and solid cylinder, right? But the question still lies is, sir, are we gonna, okay, we have understood we have to use this formulation directly by putting n equal to 0, and you can use this for generalized one-dimensional heat conduction equation, okay? But if I talk about for a slab, and that too I'm talking about that case where both the surfaces are having the same temperature, and whenever we are having this, we know that the maximum temperature will be lying at the center line and will be having a parabolic, okay? Right, and the maximum temperature, if I am assuming this as T naught, so we can simply say that T naught is equal to q dot x square by 2k, right? Q dot x square by 2k plus T, right? That means at any distance x, if I say this is x equal to 0, this is x equal to plus L, this is x equal to minus L, that means if I put x equal to any value, I can calculate at any instant this is a parabolic, right? Right. If I talk about cylindrical case, in cylindrical case, if I say this is the surface temperature TW, and definitely in this case also the maximum temperature will be at the center line, that is T naught. Here also if I calculate T naught is equal to q dot r square by 4k plus t, right? That means at any distance r. But if I talk about your solid sphere, we are getting, let's say on the surface we are having a temperature TW and TW, and this is the temperature at the center point, which I am denoting it as T naught, the maximum temperature. So T naught is equal to q dot r square by 6k plus t, right? So if I say, let us suppose at small r is equal to the radius, so we can simply say that T temperature is tending to TW. Okay, so we can say T naught is equal to q dot capital R square by 6k plus TW. Again, a problem is how we can remember these formulation. There are three distinct cases for solid sphere, solid cylinder and a slab. Okay, so what we can do is, let us try to understand from a very simple logic. I'm representing I'm representing T naught as a maximum temperature. So T naught is equal to, for all the three cases, T naught is equal to, if I say Q dot X square, Q dot R square, Q dot R square plus T plus T plus T, right? Okay, now in slab we will be using twice, in cylinder we'll be using 4, in sphere we'll be using 6. That means in slab, solid, cylinder and sphere we'll be using 2:4:6. A simple technique to remember. That means if I put X equal to 0, we'll be getting the maximum temperature. If I put R equal to 0, we'll be getting the maximum temperature, that is T naught. Here also the same. Okay, that means if I put X equal to L, right, you'll be getting T naught is equal to Q dot L square by 2K plus TW. Okay, if I talk about the second case, T naught is equal to Q dot capital R square by 4K plus TW. And if I talk about the third case, T naught is equal to Q dot R square by 6K plus TW, where TW is a temperature when small r tends to capital R, T tends to TW. For both the cases, that is cylinder and sphere. So in this way, we have understood two small tricks. One is how we can get the generalized one-dimensional heat transition equation by simply getting this equation, by using this equation at n equal to 0 we are using for a slab, rectangular system, n equal to 1 for a solid cylinder, and n equal to 2 for a solid sphere. And simply, if I want to compile these three equations, for slab we'll be using 2, for cylinder we'll be using 4, and for sphere we'll be using 6. And by this way, we are able to get a very easy questions. We are able to solve very easily whatever question they're asking from this particular segment. Okay, this is all about a small short trick from the concept of heat generation. So I hope you all enjoyed. Please do share this video to all of your friends and do subscribe to this channel for all such awesome contents. Thank you guys. Bye bye. Take care. Stay safe. Thank you.